Welcome back, everyone. In this lesson, we're going to talk about mortgages and student loans. There are three basic types of loans that most undergraduates might consider. There are federal loans from the government, there are loans that are made by banks that are guaranteed by the government, and there are private loans. The loan term can vary depending on how much you borrow, but the standard amount is 10 years, and your payments are generally deferred until 6 months after you graduate. And really, that's the big difference between a regular loan and a student loan. Student loans you don't have to pay until a time after you graduate. But in some cases, those student loans will accumulate interest while you are still in school. And so your balance will increase up to the point where you graduate and start paying it off. Interest on student loans is simple interest. It's not compound interest. It only accrues on the principal balance, and while you're in school, the amount that accrues each month remains constant. So if the principal balance of a loan is $6,500 and the interest rate is 6.8% annually, how much interest would you accrue in a year? Well, remember that the interest is equal to P times R times T for simple interest. And so that's $6,500 times 0.068 times 1. And the amount of interest in 1 year is $442. If we want to find the daily amount of interest that accrues on the loan, we just want to take the value that's accrued in a year, $442, and divide by the number of days in a year. We're going to use 365.25 because it's the most accurate representation of the number of days in a year. And so to find the daily amount of interest, well, that's $442 per year divided by 365.25 days in a year. And we find the amount of interest per day, $1.21 per day. There's a reason that we want to use the value for each day as opposed to for the whole year, which we'll see in the next example. So how much interest would accrue in the month of August? Well, the month of August has 31 days. And so if we have to pay $1.21 per day times 31 days, the amount of interest that would accrue in August, $37.51. February only has 28 days. And so the amount of interest that would accrue then would be slightly different, 121 times 28. And the amount that accrues in February, 33.88. So we can find the daily interest amount by just taking the principal balance and multiplying it times the interest rate and dividing by the number of days in a year. And then we can find the monthly interest by just multiplying by however many days are in that month. So if we look at our $6,500 student loan, if you start school in August and you graduate in May, 3 years and 9 months later, and you begin payments 6 months after graduation, that means you've had 4 years and 3 months before you start beginning payment for your loan. So how much total interest will accrue before you begin your payments? We know the amount of interest that will accrue in a year, 6,500 times 0.068, which was $442. And so we have 4 years for that amount to accrue. And so 442 times 4 will give us the amount for those 4 years, $1,768. And then we have 3 months before the payments begin. If we graduate in May, 3 months later would be August, and that would make it 4 years. And so the months we have to find the interest amounts for September, October, and November. September and November both have 30 days. October has 31. Our daily amount was $1.21. 1.21 times 30. $36.3 in September, $36.3 in November. Both have 30 days. 121 times 31, that was the answer from the previous problem. 37.51. And so to find the total amount of interest accrued before your payments begin, you're going to add up the amount from the first 4 years and then the next 3 months. And so the total interest, $1,768 plus 36.3 plus 37.51 plus 36.3. The total interest is $1,878 and 11 cents. So Max borrows $11,500 for her last 2 years of college and acquires a federal loan at 6.2% interest. Find the monthly interest for 30 and 31-day months. Well, we know the principal balance, $11,500. The interest rate is 0.062. And then to find the daily amount, which is what we need first, we're going to divide by 365.25. We find the daily amount of interest accrued, $1.95. So for 30-day months, 1.95 times 30, 58.5, so $58.50. And for 31-day, $60.45. Find the amount of interest that accrues if she acquires a loan in August, graduates 2 years later, and then payments begin 3 months after that. She'll have 2 years of payments. The yearly interest is $11,500 times 0.062, or $713. And so we're going to have $713 for 2 years, $1,426. And then the 3 months after August are the same 3 months from the previous example, September, October, November. September and November have 30 days. October has 31. And so the total interest, $1,426 for the 2 years, plus $58.50 for September, $60.45 for October, $58.50 for November. And when we add all of those up, the total amount of interest, $1,603.45. Whenever interest is covered by the government while the borrower is in school, we call that student loan subsidized. If the interest is added to the principal while you're in school, then the loan is unsubsidized. Whenever monthly payments begin on a student loan, they're based on the principal balance at that point in time. And so if you want to calculate the payments based on a 10-year term, we can use the same monthly payment formula, slightly adjusted to include the value already predetermined for 10 years. So this is the same formula from the last chapter, it's just specific for a 10-year student loan. So we want to find the monthly payments for Max's loan from example 3. To do that, we've got to determine the principal at the point where the payment begins. So we know how much interest is accrued when Max graduates and starts repayment. The interest from the last example was equal to $1,603.45. The principal, the amount that was borrowed initially, $11,500. And so now when your student loan is starting to be repaid, you have to pay back the amount equal to the principal plus the interest. And so the principal at the point where the payment begins is the sum of those two, $11,500 plus $1,603.45, $13,103.45. Now we want to calculate the monthly payment. So the monthly payment, $13,103.45, times the interest rate divided by 12, so 0.062 divided by 12, 1 minus 1 plus 0.062 divided by 12, raised to the minus 120 power. Remember that the exponent here is just the number of payments. In 10 years, you would make 120 payments. If we calculate these values, in the numerator we get 67,7011. Remember not to round until the very end. And then in the denominator, 0.062 divided by 12 plus 1, and then raise that value to the negative 120th power, and you get 1 minus 0.538803.775. Just simplifying a little bit. 0.461196.225. And then when we divide, you get a monthly payment of $146.79. Student loans are very common for college students. Home loans are very common for just about everyone. The most common home loans are paid over a 30-year span. And it's really a major commitment And so it's important that you understand the math that goes into this process. So in the remainder of this section, we're going to talk about understanding how to use math to be a more well-informed home buyer. So a mortgage is just a long-term loan where the lender has the right to seize the property if you don't make the payments. Homes are the most common items that are bought using mortgages. The most common mortgage term is 30 years, but there are terms available from 15 years to as many as 50 years. When you have a fixed rate mortgage, the rate of interest remains the same throughout the entire term of the loan, and so the monthly payments essentially will stay the same the entire course of the loan. If you get an adjustable rate mortgage, the rate of interest can fluctuate. It can increase or decrease, so your payments could go up or down. If you start off with an adjustable rate mortgage, it'll start out with a lower interest rate, but by the end of it, it could wind up being a much higher interest rate. So it's important to know if you have a fixed rate mortgage or if you're going to have an adjustable rate mortgage. So one of the most useful things you can do is calculating how much money you'll actually pay over the lifetime of a loan for a house. Let's say a family plans to buy a home for $224,900 and you have a 30-year mortgage with a rate of 5.5%, so long as they make a 20% down payment. So first let's calculate the down payment and the amount that they'll have to borrow. Well, $224,900. If we want 20% of that for a down payment, then we're going to have to come up with $44,980. The amount you would then have to borrow is the cost of the home minus the down payment. And so the amount you need to finance, $179,920. So we know the monthly payment from this loan is $1,021.57. How much are we going to actually pay for the home? What's the total installment price in this case? Well, it's the monthly payment times the number of payments, 1,021.57, times the number of payments in 30 years, 30 times 12. You'll make 360 payments in 30 years. So the total amount that you'll pay, $367,765.20. Then you want to add to it the down payment that you paid, $44,980, and the actual cost of the home by the time you've finished paying for it, $412,745.20. Nearly twice the original cost of the home. So the Tressa family agreed on a price of $229,500 for a home. Their credit union offers them a 5% 20-year loan with 15% down, with a monthly payment of $1,287.50. Find the down payment amount and the total amount they'll pay for the house. Well, the down payment is going to be 15% of $229,500. So if we multiply that times 0.15, 15% of that, $34,425. The monthly payment, $1,287.50, times 20 years times 12 months in a year, $309,000. So the total amount paid for the home, we're just going to add these two values together, $343,425. So let's go back to our first family. They get another mortgage offer that has a 10% down payment and a 5.8% interest rate. So let's figure out what the monthly payment would be. To do that, we need to first figure out how much we have to finance in this case, because we only have to have a 10% down payment. The cost of the home for the first family was $224,900. We're going to make a 10% down payment, and so the 10% down payment, $22,490. So the amount that we're going to need to finance is going to be the difference between the home price, $224,900, and the down payment, $22,490. When we subtract the two, the finance amount is $202,410. And now to find the monthly payment, M equals $202,410 times 0.058 divided by 12, divided by 1 minus 1 plus 0.058 divided by 12 to the negative 360. This is the number of payments in 30 years. If we calculate these values in the numerator, 978.315. In the denominator, 0.058 divided by 12, plus 1, raised to the negative 360 power, and then 1 minus that answer, and you'll get 0.823742,362 for a monthly payment of $1,187.65. So if we want to know how much they would spend on this mortgage compared to the first one, well, on the first mortgage they spent $412 or $412,000, $745.10. To calculate the value here, we want to take the down payment, $22,490, add it to our monthly payment times 360 for the number of payments. That's $22,490 plus $427,554 for a total price of $450,000, $450,044, $35,000 more than the first mortgage. So what if the family, from example 5, made the 20% down payment with the 5.5% interest rate, but for 15 years instead of 30? How does that change the amount that's paid for the home? First, with the 20% down payment, the house was $224,900. Down payment is 20%. So again, $44,980. The amount we need to finance is the difference. And so the financing amount here, $179,920. We know our interest rate in 15 years, the number of payments is 15 times 12, or 180 payments. To figure out the monthly payment, we're going to multiply the amount financed, $179,920, times the interest rate divided by 12, 0.055 divided by 12, and then divide by, from that formula, everything in the denominator, 0.055 divided by 12, to the minus 180. If we calculate these values, in the numerator you'll get 824.633333. In the denominator, 0.560938,213. And then we divide those two. The monthly payment, $1,470.10. So if we make a down payment of $44,980 and then pay $1,470 for 180 months, $1,470.10 times 180, that's our total payments, $264,618. And then we add our down payment of $44,980. So the total cost of the home, $309,598. Almost $100,000 less than the 30-year mortgage. Now the monthly payment goes up significantly, but if you can afford the monthly payment, you'll save $100,000 on the home, and you'll have it paid off sooner. After you secure a mortgage or even a loan from some places, the lending institution will prepare what's called an amortization schedule. The schedule shows what part of the monthly payment is interest and what's principal, and you can calculate it for each month. To compute that schedule, you're first going to find the interest for the first month using the simple interest formula, and you're going to let T be equal to 1 over 12. 1 over 12 just implying 1 out of 12 months of the year. You then subtract the interest from the monthly payment to find the amount that's paid on the principal, and then subtract that amount from the principal to determine the new balance on the account. And then you just repeat this process until the balance of the loan is paid, or until your number of payments runs out. So we're going to do a little bit of practice with this type of schedule. So we're going to go back to family 5 again. They have a principal on their loan of $179,920. Their rate is 5.5%, and they have a monthly payment of $1,021.57. So we can figure out this amortization schedule for the first 3 months. The interest here, I1, is equal to the principal times the rate times time. The principal here, 179,920. The rate is 0.055. And remember, for t, we're going to use 1 over 12. That gives us an interest amount for that first month, 824.63. And so that's what we'll put here. Now, the monthly payment is $1,021.57. So it's more than the interest. So some of that money is going to pay down the principal. To figure out how much, we're going to subtract the interest from the monthly payment, minus $824.63, and that'll tell us how much we've paid on the principal. $1,021.57 minus $824.63. The amount paid on the principal, $196.94. And so to find now the balance of the loan, you take your previous balance and subtract the amount you paid on the principal. So 179,920 minus 196.94, 179,723.06. For the next row, we're going to calculate the interest based on the current balance. So I2, now the principal 179,723.06 times 0.055 times 1 over 12. The interest here, 823.73. To find the payment on the principal, we then just take the monthly payment and subtract the interest, 1021.57 minus 823.73, and the amount paid on the principal, 197.84. So then we just repeat the process. We subtract that amount from the principal. We get a new balance of 179,525.22. Then to find the next amount of interest, we're going to calculate it from our new balance. 179,525.22 times 0.055 times 1 over 12. That'll give us an interest amount of 822.82. The monthly payment, 1021.57 minus 822.82, 198.75. And then when we subtract 179,525.22 minus 198.75, you get 179,326.47. So notice that each month the amount of interest that you pay goes down, the amount you pay on the principal goes up, and the balance of the loan decreases. So that after, in this case, 360 months, that balance will go down to 0. But also notice that from the outset you're paying way more in interest than you were paying down on the principal. So this is a little bit of a complicated process to do by hand, but it is possible to do this in Excel. So we're going to take the Tristle loan from the previous example with these following parameters: $195,075 principal, a 5% interest rate, and a monthly payment of $1,287.50. And I'm going to use Excel to show you how to generate an amortization schedule for the first year. So I'm going to pause just a moment and switch over to Excel. So here we are in Excel with our information from the problem. We know the balance of the loan, and we're told the monthly payment amount. And the interest rate is 5.5%. Now, I've added this file to this week's lecture notes so that you can practice with this file if you would like to. To calculate the interest for this loan, we want to calculate the balance times the interest rate of 5.5% or 0.055 times 1 over 12. And so in this cell we can type equals. Because we're multiplying times the balance, equals, we can just click this cell here. So the balance times the interest rate of 0.055 times 1 divided by 12, and that'll give us the interest amount, $880.34. To find the payment on the principal, we want to subtract the interest from the monthly payment. So this equals $1,287.50 minus $880.34. Payment on the principal is then $407.16. To find the new balance of the loan, we just subtract the payment on the principal. So this is going to be equal to the balance minus the payment on the principal. And we have the new balance of the loan. So by clicking into the cells, it saved me from typing out all the numbers, but it also made it so that Excel can figure out what the next row is going to do without me typing in anything. The only thing you have to know here is you just have to do one at a time because it's reading from each of the previous calculations. You can't just fill in the whole column all at once. So if we start from payment 1, we can just click and drag this box down. That's $878. If we then just drag this box down, $409.02. So notice that the interest went down by $2. Payment on the principal went up by $2. And so the balance of the loan, and then we just repeat those steps to fill in all of the different places and determine how much we're going to pay on the principal and in interest in each of the first 12 months. Okay, so we reached the end of our 12-month schedule, and we can see how much we paid in interest each month, how much we paid on the principal each month, and then the balance of the loan after a year. Notice that after a year of paying nearly $1,300 every month, your loan has gone down less than $5,000. In your lab assignment for this week, you'll have to create an amortization schedule like this. So use this as a template or a reference if you need it. Please let me know if you have any other questions.